Welcome to The Explainer. Today, we're unpacking the real story behind the black hole mystery. We're going to completely demystify these silent giants, break down the actual incredible truth behind the science, and explore how they kind of challenge our entire understanding of reality itself. Let's get right into it. Okay, let's dive into this. For decades, sci-fi movies and pop culture have painted black holes as these massive, monstrous cosmic vacuum cleaners, just aggressively roaming the universe and swallowing everything in their path. But is that actually true? Well, spoiler alert, no, it's not. It's time to challenge the biggest myths you've been taught and look at the actual physics. Here's our cosmic flight plan for today. We're going to cover 1. The birth of a black hole. 2. The point of no return. 3. Warping space and time. 4. Falling into the dark. And finally, 5. Cosmic paradoxes and mysteries. We'll basically peel this onion from the outside in to see how these things really work. Section 1. Birth of a black hole. From theory to reality. You know, the concept of a black hole actually dates back way further than you might think, over 200 years. Back in 1783, an English scientist named John Michell proposed the idea of a star so massive its gravity could actually prevent light from escaping. At the time, it was purely a thought experiment. Then, in 1915, Albert Einstein introduces his theory of relativity, showing us that massive objects can literally warp space and time. Fast forward all the way to 2019, and the Event Horizon Telescope collaboration captures the absolute first ever image of a black hole in the galaxy Messier 87. That's over 50 million light-years away. We went from a centuries-old guess to a groundbreaking photograph. So how do these things actually form? It's a super dramatic but highly logical process. Most black holes start out as enormous stars fighting this intense, constant battle. You've got gravity pulling inward and nuclear energy pushing outward. But eventually, that massive star runs out of nuclear fuel. When that happens, gravity pulls inward without any resistance at all. The core compresses unstoppably into an impassably tiny point, which triggers a massive supernova explosion. I mean, we're talking about one of the brightest events in the universe. And what's left behind in the dust? A newly formed black hole. Section 2. The point of no return. Debunking myths. Okay, so there's this massive myth that black holes just suck everything in like a vacuum. But imagine for a second if our sun were magically suddenly replaced by a black hole of the exact same mass. What do you think would happen? Well, believe it or not, Earth would continue orbiting almost exactly as it does right now. We wouldn't get sucked into oblivion. I mean, sure, the only difference is we'd completely lose our sunlight, but gravitationally, we'd be fine. Black holes basically behave just like other massive objects bound by standard orbital mechanics. They only become dangerous if something gets extremely close to them. Now, if you do get extremely close, you're going to encounter a very crucial boundary: the event horizon. This is the literal point of no return. Once anything at all crosses this boundary, escape becomes completely impossible because not even light can travel fast enough to overcome the gravity. It acts exactly like a one-way door into the unknown. If an astronaut crossed it, an outside observer would never, ever see them emerge again. They'd just be gone. 26,000. What this number represents is actually deeply fascinating and honestly a little comforting. In our very own Milky Way galaxy, sitting right at the center, we have a supermassive black hole called Sagittarius A star. It contains millions of times the mass of our sun. But, and I really want to reassure you here, it is 26,000 light-years away from Earth. Space is incredibly vast, and despite its massive size, this giant poses absolutely no threat to us whatsoever. Section 3. Warping space and time. The relativity squeeze. Prepare to get your mind blown a little bit, because black holes don't just mess with space, they mess with time itself. Imagine you're holding two identical clocks. You leave one here on Earth, where time ticks totally normally, but you take the other clock and you move it right up close to a black hole. According to Einstein's theory of relativity, extreme gravity can actually slow down time. So when you compare them later, the clock near the black hole would show that significantly less time has passed. To someone watching from far away, time appears to basically stop right at the event horizon. This is a real thing called gravitational time dilation. And while it sounds like absolute sci-fi, it's been confirmed by actual scientific observations. Section 4. Falling into the dark, crossing the threshold. Okay, so what actually physically happens if you fall in? Well, if you approach a smaller black hole, you encounter a highly terrifying visceral effect called spaghettiification. Yes, that is the real scientific term. Because gravity changes so drastically over such short distances near a small black hole, if you fell in feet first, your feet would experience much, much stronger gravity than your head. The result? Your body gets violently stretched into a long, incredibly thin shape, literally like a piece of spaghetti. So, the crucial takeaway here is that your experience completely depends on the type of black hole you're falling into. With a small black hole, you get lethal spaghettification and violent stretching right off the bat. But with a supermassive black hole, the pull is much more even across that vast boundary. You might actually cross the event horizon in a completely smooth, unnoticeable transition. You literally wouldn't immediately feel anything unusual. But, of course, once you're inside, you can never, ever get back out. And as you continue falling toward the absolute core, you eventually hit the greatest mystery in all of physics, the singularity. This is believed to be the exact point where all that massive matter is compressed into an infinitely small space. The density becomes infinite. The known laws of physics break down completely. Honestly, this realization is just staggering. This isn't just a really, really heavy object. The singularity represents the literal edge of human understanding. Einstein's famous equations, they just simply stop working here. We have absolutely no mathematical way to describe what truly happens at this infinite point. Section 5. Cosmic Paradoxes and Mysteries, the Edge of Science. For decades, the scientific community thought black holes were eternal. Once they formed, they just lasted forever. But in 1974, physicist Stephen Hawking proposed something completely astonishing. He suggested that black holes actually emit tiny, tiny amounts of radiation, which we now call Hawking radiation. And because of this, over incredibly long periods of time, black holes gradually lose mass and eventually evaporate completely. So yeah, they do die. But Hawking's brilliant discovery created a massive, massive problem. According to the rules of quantum mechanics, information can never truly be destroyed. It's a bedrock rule of physics. But wait, if something falls into a black hole, and then that black hole completely evaporates into absolutely nothing, the information inside appears to be permanently erased. This intense contradiction is incredibly famous in the science world. It's known as the black hole information paradox. So where does the information actually go? Scientists are fiercely debating this profound question right now. Some experts believe the information gets stored right on the 2D surface of the event horizon. Others think we need entirely new theories of space and time to figure it out. Some highly speculative models even suggest black holes could be connected to wormholes, basically acting as shortcuts through space-time to other dimensions. Though, to be clear, there's absolutely zero proof of that yet. The sheer fact is, we just don't know the answer. Now, you might be wondering, why does all of this matter to us? Well, black holes are the ultimate natural laboratories for studying extreme physics. By figuring them out, scientists hope to understand the true nature of gravity, unify the grand rules of quantum mechanics and relativity, discover entirely new laws of physics, and learn exactly how galaxies, including our very own, evolve over time. Solving the black hole mystery essentially means unlocking the ultimate secrets of reality itself. And the best part is, we're making extraordinary progress. Modern observatories like LIGO are literally detecting black hole mergers right now through gravitational waves. These are those tiny ripples in the fabric of space-time that Einstein predicted all those years ago. We're actively recording cosmic collisions happening millions of light years away, opening up a totally new way to study the cosmos. We are pushing the boundaries of modern science every single day. Yet it seems like every new answer just creates even more questions. So I want to leave you with this to think about. What really lies beyond the event horizon, and can information truly disappear forever? Far from just being destructive cosmic monsters, black holes are silent, invisible giants that hold the deepest secrets of our existence. As our technology advances, the answers to these mysteries might one day transform absolutely everything we know about the cosmos and our place within it. Keep looking up, keep asking questions, and I'll catch you in the next explainer.